session. So I'm really surprised to see more than 50 attendances, which is really awesome, I guess. It is even more awesome because it is a very, I would say, yeah, it's some kind of a deep dive I will try to do about parallelism, and parallelism is definitely something you can read a lot of articles, blogs, and everything like this, and there's a lot of confusion about parallelism and cost threshold for parallelism and all these kind of things, so which I will try to answer. Yes, so that's me. I was already introduced by Kevin, so maybe the most important one is my email address. So feel free to reach out to me if you have any kind of questions with regards to SQL Server, especially performance tuning on large environments. I cannot I cannot promise to answer your question, but maybe I will. Let's see. Okay, so that was me. That was the last PowerPoint presentation I'm going to share with you. So everything else I'm going to share is just code, because I guess it makes sense to see how a SQL Server internally, I can say, behaves in terms of parallelism. So cool. So what I'm going to do is I will create some test table here, as you can see here, which we will use later on. I guess it depends how far I will go, or I'm able to go within an hour, because this is by default. This is really by intention. I'm not able to finish. Yeah. So that is not because I'm not too fast. It is because I would say the subject, the topic parallelism, is really too difficult to explain something like this within an hour. But nevertheless, I guess it is still valid, what I'm going to show. And I hope that you will learn something about parallelism. So what you can see here is I created a test table within AdventureWorks, so nothing special about it. It has, I guess, if I do not misunderstand my own calculation, we have something about 1 million rows here. I'm creating another table. This is just for preparation, so nothing really special. I just want to have some data which we will use later on. It's 1 billion rows, and another one which we are going to join later on. Just a simple table which consists of 1 million rows. That's the idea. Okay, so otherwise it's really hard to hit the cost threshold for parallelism in order to see a parallel execution plan, as we will see later on. That's all. I didn't remember if okay, the primary key was there. That was about preparation. So nothing else is really needed in order to introduce you to parallelism. But we will start very simple, as always, and we are going more and more into depth later on. So what is parallelism? Parallelism means that SQL Server, or the SQL Server query engine, and for sure the storage engine in the end, can execute a query in parallel. That means a query can use more than one core at the same time. So the idea is for sure that parallelism can improve your performance. I mean, not your, but the query performance. But to be honest, I will show you later on several examples where parallelism is bad in terms of performance, because in a normal OLTP system, so online transactional processing system, an ERP system or whatever, not a reporting system. Yeah, so this is different. But in an OLTP system, you should avoid to have a parallel execution plan for several reasons, as we will see. It is definitely slower. Yeah. So in most of the cases, again, this is really, really important to emphasize. Most of your queries in an OLTP system will run slower if the query is executed in parallel. Okay. And that is a reason why you really have to think about cost threshold for parallelism. You think about, tuning your query in order to reduce your estimated subtree costs. Yeah, so the entire cost of the query. By the way, it's really just an estimation. Yeah, it's never ever the actual cost. It's something which we will talk about later on. So in order to reduce your cost, you can, I don't know, apply indexes. You can do a lot of amazing stuff here. So that SQL Server does not even have the possibility to run your query in parallel anymore, because the cost which is estimated is less than your cost threshold for Probabilism, which you can set on SQL Server. So the reason why Parallelism is sometimes, and especially in an OLTP system, often slower, is because of the overhead. I mean, you need to think about what it means when SQL Server needs to execute a query in parallel. We have to have some kind of a so-called coordinator thread. So for the moment, let's consider there has to be one thread, who has to coordinate all the work which is done in parallel, by the other threads. So that is some kind of an overhead. As we will see, it will also requires more memory, and everything like this. So make it very simple. Because of the overhead, it is very likely that your query is running slower. Again, not in a reporting system. A reporting system definitely benefits from parallelism, because we can use column store indexes, which are working very, very well with parallelism, but that's it. So in order to, or first of all, we need to understand which kind of criteria must to be met in order to see parallelism. So you can see that SQL Server must be running on a multiprocessor, multi-core, or hyper-threaded machine. I mean, in these times, this is, I've never ever seen a single processor or a single core machine. So the processor affinity configuration must allow SQL Server to use at least 2 processors. We will talk about affinity configuration or the processor affinity later on. So maximum degree of parallelism must be set to 0 or more than 1. So we will see this later on. Maximum degree of parallelism configuration for a resource governor, so an enterprise feature, must also allow the use of parallel plans. By the way, there is a lot of background noise. Can you do me the favor and can you go on mute, please? Thanks a lot. The estimated cost to run a serial plan for query is higher than the value set in cost threshold for parallelism. So I would say we have some kind of criteria which have to be met, so that SQL Server really considers to run a query in parallel. There is no guarantee. We will not see, because this is in the very end of the presentation, but there are some operators within the execution plan which cannot be executed in parallel because of the algorithm which is applied by this operator. And if I remember correctly, I'm not sure whether this is still true, but some kind of a index backward scan is still not possible in a parallel execution plan. So at least, even if the latest is not true anymore, you can see that not every single plan can run in parallel because of the shape of the execution plan. Okay, so this is definitely something you have to do on every machine. First of all, let me try to present on, I think it is very small for you, present on. I hope it works better, at least this one works better for you. This is a little bit too big for me, because otherwise I have to scroll that often. So people will always complain about when I scroll too often, because it makes people nervous. So, okay. So what I was asking SQL Server is about the current CPU setup. And so you can see that I have a hyper-threaded machine. So it's my laptop in front of me. I'm working with a laptop. So I have one physical CPU, which is hyper-threaded. So that means I have 8 cores available running on one CPU. So from that perspective, my SQL Server can run queries in parallel, for sure. Otherwise, if I would see in a 1-1-1, it just wouldn't be possible. Okay, so what is about the processor affinity? So I will show the processor affinity from a GUI perspective. Maybe it's better. let me go to processors. So we can see we have, on my machine, we have one NUMA node. We will talk about NUMA node later on. Within the NUMA node, I can see that I have 8 cores, one physical node, which is, or one NUMA node, which is, in my case, the physical core. So very important to consider when you set up your processor affinity mask, and also when you talk about the maximum degree of parallelism. But anyway, so first of all, what you should do is you need to think about the cost threshold for parallelism and the maximum degree of parallelism apart from the processor affinity mask. So let me do this by T-SQL. I mean, you can do the same in, I will show it to you because some people tend to use CGUI instead. I really hate this, but this is the place where you can change it, cost threshold for parallelism, and also maximum degree of parallelism. So currently it's set to 50, the default is 5. Let me change this so that everything is running with a default. So I don't know why this is so, I can see the problem. Okay. Okay, it's either or. Let me do this. I mean, I know that I can change this in fonts, but this is a little bit too complicated for me now. Okay, so bear with me. I hope you can still read it. I mean, this is something you should read, otherwise, I mean, you have other problems, I would say, here in the message box. I hope you still can see it and also the result. So we can get the same information from these configurations. We can see that the cost threshold for parallelism is set to 5 now. Maximum degree of parallelism is set to 0. So, and we can see we have 8 cores available. And we have an affinity mask, which is also very important to understand. So the affinity mask is currently not set. So that means SQL Server does not have a specific affinity mask set so far. So let me execute this one. And I will give you an example how these kind of settings will impact your execution plan. So it's a little bit too, okay, that's some kind of compromise. Okay, so I will first of all use AdventureWorks 2017, and I clear the procedure cache just to ensure that there are no leftovers in my procedure cache. I mean, I'm using option recompile anyway, so we should not even see a plan in the procedure cache because of option recompile. But anyway, so we are using one of the tables which consists of 1 million rows, if I remember correctly. And I will execute the actual execution plan. I mean, we can do the same with the estimated one, but it is fast. We can see we have a parallel plan. So, and this is so super annoying. I don't know. Okay, good. You can see what happens. So we can see several information. So first of all, this kind of double arrow indicates that this operator is running in parallel, and every parallelism or parallel plan ends up with a gather stream. That means, so the threads which are currently working in parallel here does not even know what the other thread is currently doing. Let's describe it in this way. But in the end, the gather stream will collect all the information from, in my case, 8 threads, right? You consider this, you need to think about it is multiplied by 8, and in the end, the gather stream will combine all threads. So in the end, we have one select operator in the end, which will indicate the estimated subtree cost, which is 24. So that is already very important. So the estimated subtree cost is 24, which is more than my current cost threshold for parallelism, which I set to 5. And that is the reason why SQL Server now considers to use a parallel plan. So you know that whenever SQL Server optimizes the query in order to find a so-called good enough plan, the cost which is evaluated with a plan, which is found at that point in time, is important. So when the cost is too high, I mean, there are internal thresholds, SQL Server will use or will apply more, what can I say, more rules, more algorithms, and more simplifications in order to reduce the costs, right? And within a given time. That is really important. So we have, in the end, we have 3 optimization phases when we do not have a trivial plan. So, and I would say the more expensive a plan is, the more operations, the more simplification SQL Server tries to do in order to find a plan which is, I would say, which is cheaper than the cost threshold which is set on that specific optimization level. And that is in the optimization level 1 and optimization level 2. So we will start with 0. That is why we have 3 phases. SQL Server will consider the first time parallelism. Yeah. So when you have a trivial plan, or when you have, I would say, a query which can be optimized already with the optimization phase 0, which is the first phase, SQL Server does not even consider parallelism, but it also means, as we will see later on, so that SQL Server have to run at least 2 iterations, or to be precise, at least 3 iterations for the very first optimization, and also for the second optimization phase, but 2 times, because it will compare the serial plan with the parallel plan. So this is something which we will see. This has some kind of an impact on your on the compile time. So, and for whatever reason, I forgot to enable statistics. So sorry for that. I'm pretty sure I have it somewhere, but I didn't execute it, that one. So let me do this and do it another time. Because, and again, we are starting simple. Yeah? We are going more and more into detail, but it doesn't make sense when I go already into detail and the basics are not clear. So same plan as before, for sure. So what is important from that perspective? So you can see here, so big table is scanned 9 times. So this is because of parallelism. So this is 1 plus 8, because currently when you see the degree of parallelism here, I should see a degree of parallelism, to be honest. Why I'm not able to see it? Thread starts here. Thread starts. So currently we have 8 threads which were used. Okay, and we can see it also from that perspective. Scan code of 9, which means is 1 plus 8. So every single thread scans the big table in order to get or to scan the specific portion of pages. So you can imagine that you have something like a so-called page supplier here in the very beginning, which is not visible for us, but the page supplier will take care about the I would say the pages which will send to each thread in order to avoid that the other thread will scan the other tables another time. So we will see this later on also here from that perspective. Anyway, that's it. So you can see from a CPU perspective, we can see in this case, it isn't very obvious, but sometimes you can see something like this. Let's say we have 5 seconds or 5,625 milliseconds CPU time and an elapsed time of 3 seconds, right? So it is not the case here, but when you see something like this, it's very clear that, I mean, the CPU time is now measured on every single thread, so on every single core. That means in the end, you need to divide this by 8. I mean, this is never ever equal, but divide this by 8, then you know the time which is spent in average on every single core. That is the reason why sometimes the CPU time is higher than the elapsed time, which wasn't the case here, but sometimes, very often, you can see this in a parallel plan, CPU plan, as the CPU time is higher than the elapsed time, right? So when you see something like this, you know already why. So this is too big. Okay. When I now tell SQL Server, or when I now configure the affinity mask, which is sometimes really helpful, but first of all, I will execute the query. So we can see that this time the sorry, wrong. I need to execute the same query another time. This was just to ensure that the affinity mask was set correctly. So when we are now executing the same plan another time or the same query another time, we should see that the plan shape is different because SQL Server is not allowed anymore to use more than one thread because of the more than one core and therefore more than one thread. Yeah, because of the affinity mask which was set. Yeah, so that means from that perspective, we can also use or ask SQL Server about DMO's schedulers, and we will see that there's only one visible, here you can see it, one visible scheduler available. So you can, I mean, it's not really precise, but you can consider a scheduler as a core. This is really not precise, but at the moment, let's consider one core has one scheduler. Yeah, so that is the reason why we can see 8 schedulers, which is nothing else than a logical object on top of the processor. And only one is visible. One line, you can see it here. That means SQL Server cannot use more than one scheduler and therefore not more than one core at the same time, right? It can still, as we will see, use other cores, but it cannot use more than one core. So yes, so when I now execute the same query, you can see already it wasn't working. Okay, it was working, but just with one thread. So therefore we couldn't see a parallel plan anymore. So I will do undo and everything. Hopefully it is really the reset. Otherwise I'm really in trouble. I will do it another time. So I set the cost ratio for parallelism to 5 another time, maximum degree of parallelism to 0. So SQL Server can use all my cores. So, what is the maximum degree of parallelism? Sometimes really handy, and honestly, I was a little bit surprised. I worked with a customer, and they installed SAP or SQL, yeah, SAP together with SQL Server. So SAP was running on SQL Server, and SAP set the maximum degree of parallelism on a database level to 1, which is great. Because every single user request outside SAP was single-threaded. But internally, SAP has overwritten the use of the cores, so the maximum degree of parallelism, to, I didn't remember anymore, to 8 or whatever. That means with this process, SAP can ensure that the SAP queries always have all the cores available. And when you run something on SQL Server outside SAP, you only get one core. So your query can never, ever rerun in parallel. I mean, it's really handy for SAP, but causes a lot of trouble when you use SQL Server for, I don't know, for reporting purposes at the same point in time, yeah, and not from SAP. So this is about maximum degree of parallelism. You can see it is currently set to 0. So now we need to talk a little bit about NUMA nodes. I mean, we will do it later on another time, but I will already do it at that. 1 second. Yeah, okay. Picture which I took from the internet. I didn't remember anymore where I took it. It's not really important because we have several thousands of images about the NUMA node. So when we talk about maximum degree of parallelism, we need to consider the current NUMA configuration of your server, because the idea is the following. You remember that my machine only have one physical core. Within my physical core, I have only one logical NUMA node. So SQL Server since SQL Server 2017, if I remember correctly, is able to create logical NUMA nodes when SQL Server starts, when the number of cores is more than 8 or 16. I didn't remember anymore, and Microsoft changed the configuration over the time. But this is already an indication that you need to consider about the NUMA node configuration and also the maximum degree of parallelism. The idea is the following. Let's consider we have a machine with 4 physical CPUs, and let's consider we have 8 cores within one physical CPU. So one CPU is normally considered as one logical NUMA node. So a logical NUMA node has 8 cores. The reason why this is important with regards to your maximum degree of parallelism is the following. When I tell SQL Server only to use 8 cores at the same, and that is not true, but for now, let's say it, 8 cores for the same query. So that means you do not have more than 8 threads available in a query. SQL Server does not need to exchange data across the NUMA nodes, and therefore does not need to exchange data between the physical cores. So when you exchange data within the same core, this is something which can be done by the cache, which is really, really, really fast. When you need to exchange data between the physical CPUs and therefore logical NUMAs, it can take much longer, up to, I don't know, 30. I've seen, you can evaluate this by, there was a tool which I didn't remember, CPUs, core.info.exe, if I remember correctly. So you can see the latency between the cores, and I've seen latency more than 30%. That means when you now run a query which needs, or which will allocate more than 8 threads, so you leave one NUMA, you leave one physical core, physical CPU, SQL Server now has to exchange data between the cores, and for sure also between the physical CPUs. That means there's a bus involved, yeah, to transport the data, and this has a latency of 30%. I mean, when you now know your CPU, so the speed of the clock speed, and you know that you are already reduced by 30% just by moving data to another physical core, you can already imagine what kind of performance bottleneck you have here. And again, in most of the cases, at least from an OLTP perspective, there is not even a need to have parallel queries. So why should I even execute or exchange data between physical cores then? I mean, at least I can ensure by setting the maximum degree of parallelism to 8 that SQL Server will never ever exchange data with another physical core, because it is allocated to this NUMA, and it will never ever leave this NUMA anymore when SQL Server executes the query. That is the idea. So that means ensure that your maximum degree of parallelism is aligned with the cores, with the number of cores within your logical NUMA node, because otherwise, again, you're losing already a lot of CPU cycles. Yeah, so let me go down. Execute. Okay, so what I'm going to do is, I mean, you know the query already. It is running with, let me just visualize the estimated execution plan. So we can see the degree of parallelism is 8. We know it already. So now I will change the maximum degree of parallelism to 1. So, and therefore, this is the other, I would say, criteria which needs to be met. So otherwise, SQL Server cannot run a query in parallel. So when I execute the same time as the same query another time, and this time I will, no, this is right. This is the actual one. Yeah. So let me see what happens here. So first of all, we can see that the scan count is 1 only, not 9 anymore, because we have only one thread. So a single threaded, right? And we can see from that perspective, there is there's not even a thread statistic anymore available. But I really wonder a bit. So normally I should see something like degree of, degree of parallelism. Degree of parallelism is set to 0. It's not very precise. I would like to see something like, I mean, it's okay. Degree of parallelism set to 0. At least we get an information here. The reason that we do not see a parallel plan is that the maximum degree of parallelism is set to 1. That is the reason. It's really important sometimes to understand why your query is not running in parallel. Maybe you expect to see a parallel plan. So often you can see a hint or the information in the execution plan, and you can see there's one property called non-parallel plan reason, and it will tell you in this case, yeah, it is you. You set your DOP to 1. So therefore, SQL Server cannot run in parallel, but would like to run in parallel. Okay, so now I have set the maximum degree of parallelism to 1, but this is the example SAP is doing. So I can override everything with setting or with giving a hint, maximum degree of parallelism to 0. So now SQL Server can again still use all the cores which are available, in my case 8. And here this is also very important when you have the setting on your maximum degree of parallelism, set it to 1, then ensure that you do not exceed the number of cores within your NUMA, which is in my case 8, when you give a query a hint like this. Okay, let me undo everything. And that's perfectly fine. I do not need to go through all the other examples here. I will do some housekeeping because this is very clear, I guess, how the property works. So what is a resource governor? A resource governor is a feature I really, really like, but unfortunately, I guess it's still an enterprise feature. I guess so. Yes, I guess it is an enterprise feature. So I'm always working with enterprise. So that is the reason why I do not really remember if it is an enterprise feature or not. But for now, let's say this is an enterprise feature. Otherwise, I mean, there's a documentation from Microsoft where you really can read whether this is available in your edition or not. Anyway, so what is about a resource governor? I do not want to execute this example, but I will guide you through the code and I will tell you what will happen, because otherwise it takes too long. So the idea is the following. You can set up a resource pool, and within a resource pool, you can set up a workload group. So you can see it here. So create a resource group pool, and you can define whatever you want to find, and which is available in your resource pool. And within your workload group, which is assigned to your resource pool, you can say maximum degree of parallelism to 2. The reason why you want to do this is the following. Maybe you have a specific classifier function, something like this, and you want to prioritize specific connections, or not prioritize, maybe that's the wrong word. You want to, how can I say? You want to impact the way the query is executed, because you assigned the workload group with this setting. You can do some other settings here as well, but maximum degree of parallelism is set to 2. That means this user, test my workload group, will use the workload group with the maximum degree of parallelism, which is set to 2. That means this user is limited by 2. And again, we will see this is not really precise, but for the moment, the query which is executed by this username cannot use more than 2 threads. Sometimes really, really good when you want to ensure that some connections will run with, I don't know, only single threaded. Some of them will run with more than one, depending on what kind of application will access your database. It depends. It is in your control. For sure, you need to reconfigure the resource governor, and in the end, when you now create the user, which is assigned to the workload group, so to the classifier function, and you execute this one, you will see that your affected maximum degree of parallelism is set to 2 as expected. The problem is the following, what I figured out, and I do not know whether this is a bug or not. When you set the degree of parallelism to 1, you still see a parallel execution plan, which is a little bit odd. I wouldn't expect it to see a parallel execution plan when I executed my query within a workload group, so the resource workload group, where I set the property maximum degree of parallelism to 1. But it is like it is. Anyway, in the end, you will see that the degree of parallelism at least will tell you, no, the degree of parallelism will tell you 0, but you can run the some investigation on the resource governor pool and the allocation of MAXDB, and you will see that in the end, for sure, the query is not running in parallel. It is running with just 1 or 2 or whatever, with 1 thread, because this is a bug here. In 2, you will see everything. That's perfectly fine. But again, when you have a single threaded workload group, you still will see a parallel plan, which is, I guess, really a bug. So what is the cost threshold for probabilism? Cost threshold for probabilism is set by to 5 by default. It is really, really old. If I remember correctly, it was something in, I don't know, maybe 30 years back, 25 years back, something like this, where Microsoft decided, or I think it was Microsoft, decided when a query will take longer, as very likely to take longer than 5 seconds, because this is something which is set before the execution even happens. So this is an estimation. It will take longer than 5 seconds, then consider to run your query in parallel. I mean, in these days, CPUs are for sure much, much, much faster. So people are asking, is this still a valid setting? And honestly, we had a conversation with Microsoft on the last MVP summit, and I mean, they're completely right to say what is the right figure here. Is this 5? Is this 50? Is this 200? It depends. So 5 is wrong, 50 is wrong, but 5 can be right, 50 can be right as well. So there is no, I would say, how can I say, there is no official recommendation to set the cost threshold for parallelism to anything else than 5. This is you. You need to analyze your workload in order to decide at which kind of threshold your query will run in parallel, and otherwise it will run not in parallel. It is on you. So it really depends on a lot of factors. So threadpool starvation, so how busy your CPU is, CXPacket, CX consumer, everything with regards to this. So SQL Server has, or Microsoft has no clue about this setting. Does not know your workload. So, but what you can see is, and I mean, this is very easy, so that is the reason why I'm not going to show the example, but you remember the query it took, or the estimated cost was something about 29. When I run it with maximum degree of parallelism 1, that means I force SQL Server to run this query in parallel. Yeah, so that these are the effective costs when I run this query in a serial way, 29. So that is the reason 29 is now for sure much more expensive than 5, which is currently set, which is the default. So SQL Server now considers to use the parallel plan. So, and now the costs are down to 21, right? Which is some kind of a cost saving of 8. But I mean, cost is something like a combination of time, memory, IOs, and CPU. So I mean, cost is completely neglectable. I mean, costs are often completely wrong because this is estimated. You will never ever see actual costs. There is no property actual cost. It is an estimation based on statistics and based on a lot of other things. So therefore, I personally do not take care about cost. For me, logical IOs and CPU time is important, even not elapsed time, because elapsed time is nothing else than CPU time plus wait time. And sometimes you are waiting on a resource which is allocated by another query, but this is not the fault of the query because it is running slow. It is another query. So that is why I do not care about cost. The only, I would say, important thing is here that when you reach your cost threshold, SQL Server will run your query in parallel. That is the only, I would say, impact of the costs. So what we can see is, and hopefully it works. Let me do the following. Here we have a query. You can see it. It's very complicated. I mean, the more joins I have, the more possible alternatives I have, and therefore, the longer it takes to find the good enough plan. There is no best plan. Only if you have a trivial plan, then there's only one plan available, so therefore it is the best plan, but not in this examples. I have a lot of possibilities because I can join table A with B or table A with C and then with B, and we have a lot of possibilities available. So I'm now going to just display the estimated execution plan, and you can see what happens. So there are some trace flags here which I use. So 8675, and for sure I can see the output in SSMS, so 3604. So what you can see here is the time SQL Server will spend on the optimization. And you can see as I already mentioned, we have several search phases. we have search phase 0, yeah, which is for simple OLTP queries, but the cost threshold for which is internally set wasn't reached. That is the reason why SQL Server now goes into the second, yeah, search phase, which is search phase 0 because it is search phase 1 because it is 0 based. And the interesting one is that you can see it was even not good enough. So we can see that SQL Server use another, I would say, I don't know, time slice, yeah, to find a better plan. And you can see how long it takes. And finally, the cost which were found by the estimated by the plan, by the good enough plan in the end. So the problem is the following. When I run, 1 second, I should see search phase 2 times. I'm a little bit confused. Search phase 1. I just need to check. 1 second. Just need to check my. It's still. Yeah. Okay, the problem is that I forgot to reset my settings. That is always a little bit problematic because nothing is working anymore. So that should work. Let me control this in the GUI perspective because otherwise I'm a little bit lost. Because all the examples are heavily impacted by the settings. Okay, now it should run. And just want to control the affinity mask because I set the affinity mask for my example. Processors, yes, that's fine. I can see it here already automatically. Okay, so now it should run. Let's give it another try. Same query as before. Yeah. I will clear the cache just to ensure that nothing is there. And will execute the same, not even execute, just display it. We are still running in I'm wondering why I'm not getting an query, a parallel plan anymore. I don't know. So sorry for this. This example is not working anymore. I need to check why. I don't really know. Because normally, I will tell you what you should see. This plan normally should run in parallel, and I'm pretty sure you will agree because the cost is 9, and my cost threshold for parallelism is set to 5. So that is 9 is bigger than 5. We should see a parallel plan, which isn't the case. I don't know why. Don't ask me. I mean, there's some kind of, I would say, cumulative updates. So sometimes the engine doesn't behave the same anymore. But anyway, the last time I executed this one, and believe me, it is not long ago, I could see that the search phase 2, this one, was executed 2 times. So we will see something like this. Oops. I can do it like this. So, and the search phase 1 was a little bit higher, I would say something like this. The search phase 1 was executed 2 times because the first iteration was considering or finding a non-parallel plan. The second one, but the same search phase, and as already mentioned, search phase 1 and 2 only considers parallel plan, not 0, and for sure not trivial plans. You can see that the second iteration was about finding a parallel plan. And now SQL Server can consider or can compare both plans in order to, to select either the serial plan or the parallel plan, because sometimes the parallel plan is not cheaper than the non-parallel plan. That is the reason why you spend more CPU cycles on compiling a plan which potentially can run in parallel. I mean, we can see it from here. I'm pretty sure because the former example wasn't working, this will not give me anything back. That's for sure. But in the end, we should see with this approach the CPU time we spend here, compile time and CPU time. So these are the CPU cycles and the time which I spend, not me, SQL Server, which SQL Server spent in order to compile the plan. Sometimes you can see, what is it, resource, what was it, resource semaphore compile memory? I guess that is a wait stat. That means SQL Server does not have enough memory in order to find a good enough plan, because the optimization happens in memory with so-called memo structures. And SQL Server needs, I would say, additional amount of memory in order to compile a query. But when the query or the memory is not available to compile the query, we will see wait type. Yeah, I guess it was a resource semaphore CP memory compiled or whatever. I didn't remember this by heart anymore, but it's very well documented. And by the way, we should see another example. Let's give this a try. Maybe this will work. At least we can see the two search phases. This is running in parallel now, because maybe I did something wrong in the very first one. Here you can see it. So search phase 1 is executed 2 times because of the parallel plan. And when I now, maybe it also works now when I run this. Do I have a hash, something like this? No, it should run. It will not give any information back. I don't know. Maybe I really need to execute the query in order to get something back. But normally an estimated execution plan should be enough. So believe me, there's something wrong with the query at the moment. I do not want to fix it. For you, it is important to understand that you spend more CPU cycles when you have a parallel plan, right? Because of at least 2 iterations on the search phase 1. Okay, so sometimes you want to or force SQL Server to enable a parallel plan, and in former times there was a query trace on which you can use within the query 8649. Now we have a hint, enable plan parallel plan preferences. And again, this is very simple. I do not want to execute this one. You can see, you can either use option. So that means in this case, the cost is not big enough, right? And you can force SQL Server to run the same query in parallel. Maybe you want to compare this to understand why SQL Server doesn't select the parallel execution plan. So you can see the cost and everything with regards to the non-parallel execution plan, and you can compare it with the with the parallel execution plan. Sometimes really handy, because sometimes you really want to see a parallel execution plan, and this you can try to force SQL Server to use the parallel plan. And then you can compare the plans, and you get a good feeling about why SQL Server is not using a parallel plan. So processor affinity mask is something I will skip because this will take a long time just to talk about this one. This is about NUMA nodes. So we will see the trace flag 8002, which is very important. So when you make it very short, when you want to set the processor and affinity mask here, so you can do it from that perspective as well here. Ensure that you set the trace flag 8002, because otherwise the scheduler this thread cannot move across the schedulers and therefore CPUs anymore. That means when you have a CPU bottleneck, because you set a processor affinity mask without the trace flag, and the CPU is busy by another process, the SQL Server have to wait. If you have 8002 in place, the thread, or the scheduler to be very precise, can move to another CPU and can do their work. So I have an example here, but really it takes at least 20 minutes just to demonstrate this behavior. Read about 8002 whenever you want to set a specific processor affinity mask, right? Okay, so let me go down. So now I want to tell you something about this is latency we have talked about. Query execution time. So what I did is the following, and this was really interesting for me, at least for me. I hope this is interesting for you as well. So I was running a query like this. So you remember the big table which I had in the very first beginning, so with 1 million rows. And for sure, the cost threshold for Parallelism set it to 5. So this query can run in parallel. But you can see I forced SQL Server to run the query with 8 cores, with 7, 6, 5, 9, 6, 5, 4, 3, 2, and non-parallel anymore. So, and what I did is I measured the time and also the wait stats, and that is the result. It is really nice to see. So that is the query execution time, and you remember the query execution time is nothing else than CPU time plus wait time. That is the elapsed time. So in this case, I mean, I was the only person on my machine, so nothing else was running, and I executed this example several times to get some kind of an average. So, and you can see what happens. So this one is single-threaded. So you can see here on the x-axis, I hope this is right. So I'm not a native, English native speaker. I hope at least you can understand what I'm talking about. We have a DOP, also degree of parallelism, 1, that means single-threaded. 2, 2 threads. Yeah. And again, this is not very precise, but at the moment, let's keep it like this. So we have 3, we have 4, and so forth, 8. So, and we can see the CPU time it took, yeah, and the elapsed time, and also the wait time. And you can see, interesting, that the execution time, I mean, almost, I would say, increases with the number of cores or threads which are used within your parallel plan. That means the more CPU, the more cores, the more threads are used by SQL Server to execute the same query, the longer it takes. And that is exactly what I mentioned in the very first beginning. This is a typical OLTP query. It's not a data warehouse query for sure. I do not have any kind of column store indexes on top of it. It's not a star schema. You know, it's a complete different kind of story. It's a query here. Yeah. The reason why SQL Server have to the query takes longer to execute is that SQL Server have to wait. It will wait for CXPacket. So what is CXPacket? CXPacket is CX, also class exchange packet. So the idea is the following. You have, let me go back to this example. You have, you remember the coordinator thread. So when I execute a query with just one thread, there is no need for a coordinator thread. But you remember that whenever we have a parallel plan, we have a parallel gather stream in the end, which combines the threads, yeah. So, and collect all the data and push it forward. So now you can consider that it is much, much more complicated to coordinate 8 threads which are working in parallel and does not even know what the other thread is currently doing. They do not know anything from each other. In the end, SQL Server have to combine these and have to wait until the slowest thread is done with the work. That means when I have 8 threads and thread number 7 is the slowest thread, thread number 7 will determine your execution time. It can be that thread 1, 2, 3, and so forth are already done, and in thread 7 have to wait for an incompatible resource, for example, a log. That means you have a log somewhere on a record, and for sure, all other pages, all other records can be read by all other threads, but this thread have to wait for the incompatible log, which is a shared log with an exclusive log. You know, you have a block, so that it will last forever, and thread number 7 is in trouble. But the overall execution time is increasing over time, yeah, because it has to wait. Maybe the log is released and the query is finally executed. Again, the culprit is not the query itself. The culprit is the other query. That is really important to understand. The elapsed time is nothing I would bother about. CPU time is important for me. So when you now consider CX consumer per definition is nothing which should worry you, because CX consumer will only, CXPacket. Yeah? CX consumer is the other side of the parallel plan. So this is the consumer side. And we have CXPacket, which is now CXPacket, I guess, minus CX consumer. That is what is going out to the next operator within the operation plan, within the execution plan, within the pipeline. Yeah. So what is CXPacket? CXPacket will just measure the time the query will spend in parallelism. So until all the threads will be combined in the end, that is the time which is measured. So when you have a CX consumer of, I don't know how many milliseconds, I don't care. because it just will tell you that your query is running in parallel, and that is the time the query was running in parallel. Nothing wrong about it. The problem now starts when you think about the impact CXPacket means your query is running in parallel. Why is your query running in parallel? Because it is too expensive. Too expensive to be cheaper than your cost threshold for parallelism, which you set on your database. In my example, 5 or maybe 50. The query is more expensive. That is the only indication of CXPacket. And now you need to think about what is the reason that your query is expensive. It is expensive, maybe you are missing an index, or maybe the query is too complicated. You write your query in a completely wrong way. So you need to fix the reason for it, but you do not need to worry about CXPacket by, I don't know, increasing or decreasing the cost threshold for parallelism. That is not the right way to do it. I mean, when you have something like meaningful cost threshold for parallelism, why should you, I would say, change the cost threshold for parallelism over time? This is not, I would say, fixing the problem. The problem is your queries are too expensive. They are more expensive than the value you imagine, which is right for your database, right? So that is why you really need to worry about CXPacket. You need to think what is the impact and the explanation of it. The other problem is the CXPacket will tell you your query is running in parallel. And as already mentioned several times, when you have a maximum degree of 8, that doesn't really mean your query will always run with 8 threads when it runs in parallel. No. SQL Server implemented, I think in 2017, that at least the first time I encountered this. When your CPU is under pressure and you see a lot of CXPacket, SQL Server can on the fly reduce the number of threads which are used by the query. Really, really interesting to see. Normally you expect to see on my machine 8 threads, but when you execute with stress or whatever, the same query with, I don't know, 400 concurrent threads, that means SQL Server will reduce the number of threads. Some of the queries will even run in a non-parallel fashion. Others are running maybe with 6 or 5 or whatever threads at the same time, but there's some kind of a limit. The limit means your maximum worker thread, which you will see in sysinfo, which is in my case 576, that is the maximum threads which are available. That means the more queries are running in parallel at the same point in time, the more threads you allocate. And this is limited by 576 on my machine. Depends on your CPU. Yeah, it's the number of CPU, because this has something to do with license and something to do with cost and also with, I would say, CPU architecture and everything like this. But nevertheless, when you reach your limit of 576, there is no thread available anymore. There is no idle thread. That means you run in a Threadpool starvation. And that is why you should bother about CXPacket. When you see CXPacket in combination with Threadpool, you are in trouble. Again, you should fix the root cause. And maybe it is also worth to increase the cost threshold for parallelism because you have something completely meaningless in your database. But as far as you have something meaningful here, like 50 or 80 or 100 or whatever, you need to find the queries which will allocate more than one thread. And I know that I'm running out of time. This was expected, but nevertheless, 1 minute about the thread allocation. So I told you that SQL Server can on the fly reduce the number of threads, but there is another, I would say, flip side of parallelism. So think about a hash join. A hash join operator have 2 phases. First one is a build phase. Second one is a probe phase. The build phase is blocking. That means until the hash table is generated, your execution will stop. That means at that point in time, SQL Server will allocate 1 time 8 threads. And then it will follow, it will continue with the query, and everything is good. Now let's consider merge, a merge join. A merge join also have two tables, because otherwise a merge join will not make any sense. It can be the same table, but at least it have to have at least two, I would say, two objects in order to compare. A merge join does not have any blocking because the input is sorted. So it's a streaming algorithm. So that means in this case, so I will start with n times 8 threads, in this case 2 times, and I also have an output. That means I will end up with 3 times 8 threads. That means my query will not only allocate 8 threads, as you might think, because your maximum degree of parallelism is set to 8. No, your query will allocate 24 threads. And now you are in trouble because you can run 2/3 less number of queries at the same time when you have a merge join comparing to a hash join. And that is what is really important to understand. You need to look at your thread statistic, as I already did. You remember we have seen 8. But again, run the same example with a merge join with a sorted input. You will see 24. And 24 so 576 divided by 24 is for sure less number of queries which can run in parallel comparing to 576 divided by 8. That is, your query plan shape will, I would say, will determine the number of cores which are allocated at the same time, CXPacket therefore, and also Threadpool Starvation. That is really important to understand. Okay, that's all. I mean, we can talk about parallelism, yeah, I don't know, for another few hours. But do you have any questions?
Amazingly, no questions. Is there some place that we can download the test scripts?
Yes, I will send you something for sure. Yeah. There's also the presentation is already shared on some of the, I don't know, SQL Saturdays. I don't know. Yeah, but I will send you something.
Perfect.